At what temperature the root mean square velocity of SO2 molecule is same as that of O2 at 27 degrees Celsius? We need to find at what temperature SO2 is same as that of O2 temperature. Now the root mean square of SO2 at which temperature the root mean square speed of RMS value of O2 is equal, we need to find. The formula for root mean square velocity is root of 3RT divided by M. Okay. I am representing here there is an SO2 molecule. So temperature at SO2 and molar mass at SO2. It is equal to, and for O2 the root mean square velocity is 3RT O2 the temperature and MO2 molar mass of MO2. And now taking squaring on both sides, now squaring, taking square on both sides. So when we are squaring both sides, this square root get cancelled. This can be written as now 3R get cancelled. Now TSO2 divided by MSO2 is equal to TO2 divided by MO2. Now our aim is to find the temperature at SO2. So is equal to, taking this molar mass in this side, T at O2 into MO2 divided by M, this is SO2 divided by MO2. We know that the molar mass of SO2 is equal to 64 gram per mole. And for O2, 32 gram per mole. Substitute in this value now. TSO2 is equal to, T is given in degree Celsius. We need to convert that as an Kelvin. So T is equal to 27 plus 273 is equal to 300 Kelvin. Now this is 300 Kelvin. Temperature at oxygen is 300 Kelvin into MSO2 is 64 gram per mole and divided by 32 gram per mole. Now this get cancelled and this one 2, this is SO2 600 Kelvin. So at this temperature 600 Kelvin only, the O2 molecule is equal, the temperature of O2 is equal. So the option 4 is the correct option. A spring undergoes an extension of 5 cm for a load of 50 gram. Find the frequency of oscillation if it is set of vertical oscillation with a load 200 gram attached to its bottom. So here we need to find the force constant. Force constant K is equal to minus F by X. F is force, okay. We know, see here, force is directly proportional to X. That is distance. If you are applying the force, the object moves here. And I am representing a constant value here, that is K. So, yeah, K is equal to minus F by X here. It is moving in opposite direction. So, force is moving in one direction and the object is moving in another direction. So, it is in negative sign. And now this can be written as F is mass into acceleration due to gravity, that is A divided by X. X is the distance of the object. Now mass they given the mass is in 50 grams. So 50 into 10 power minus 3. Acceleration due to gravity is 9.8 divided by the distance. They given the distance is in here. What is the distance? 5 centimeter. So 5 into 10 power minus 2. So on substituting this equation, you will get 9.8 Newton per meter. Okay. Now we need to find the angular frequency. Angular frequency omega is equal to root of, this is the formula for angular frequency, K by M. K is the force constant and M is the mass. And K we got here 9.8 and M mass they given the mass attached to its bottom is 200 grams. So 200 into 10 power minus 3, it is in square root. Okay. This is equal to, now we will get the value on substituting this, you will get the value 49, root 49, that is 4 radian per second. Radian per second. Now frequency of oscillation, our aim is to find the frequency of oscillation. Frequency of oscillation. So F is equal to the frequency of oscillation, F is equal to omega divided by 2 pi. We know that omega, angular frequency omega is equal to 2 pi into F. So F is equal to omega divided by 2 pi. Now omega, we get the angular frequency value as in 7 divided by 2 into pi value is 22 by 7. This can be now written as 7 into 7 divided by 2 into 2, 22, 49 divided by 44. Now this is 1.1 hertz. So the angular frequency of oscillation is 1.1 hertz. So the option 3 is the correct one. Find the electrical conductivity of an intrinsic semiconductor, germanium rod 1 meter long and 1 millimeter width and 1 millimeter thickness at 300 Kelvin. They given the value of Ni, intrinsic carrier concentration, then mobility of electron as well as the mobility of hole they given. Our aim is to calculate the electrical conductivity of intrinsic semiconductor. We know that this is valence band and this is conduction band. At T is equal to 0 Kelvin, all the electrons are bounded to the valence band and conduction band is empty. In intrinsic semiconductor, we need to give some temperature to the valence band. So the valence electron escape to the conduction band. So giving temperature, the valence electron now it is moving to the conduction band. If 5 electrons are moved to the conduction band, if here we are having 5 electron means 5 holes will be created in the valence band. 5 holes will be created. So number of electron Ne, I am representing here, that is an electron in the conduction band as Ne and electron in the holes, that is valence band as NH. So here 5 electrons are going to the conduction band, 5 holes is created in the valence band. So Ne is equal to here NH. So here I am representing, that is an Ni, that is nothing but that is an intrinsic carrier concentration. Okay. Carrier concentration means electrons as well as holes is the carrier concentration. Now applying the formula, the electrical conductivity formula. What is the electrical conductivity formula means? Sigma is equal to Ni E mu E plus mu H. What is mean by mu E? When the electron, mobility of electron, when we are applying the heat, electrical energy or heat energy, the electrons are moving from one state to the another state, lower energy level to the higher energy level. So there is a movement here. So movement of electron is mobility of electron and movement of hole is known as mobility of hole here. Now here in the valence band we will have n number of electrons and charge of an electron and mobility of an electron here mu E. And the this is for conduction band, and for valence band we will have n number of electrons and charge of an electron also, and n mu h. Mu h is nothing but that is hole concentration. Okay. Now I wrote this expression here. Ni is intrinsic carrier concentration, E is the charge of an electron, or we can write electron are here holes. Okay. And mu E represents mobility of electron and mu h represents the mobility of hole. Now apply the values here. Ni is nothing but 2.5 into 10 power 19, and charge of an electron is 1.6 into 10 power minus 19, and here they given the mobility value as mu E is equal to 0.39 plus mu h is equal to 0.19. Okay, on substituting this value you will get the answer 2.32 ohm inverse meter minus 1. So the option is here 2.32 ohm inverse meter minus 1.
Which of the following set of elements follow Newland's octave rule? Before entering to it, we have to know what is Newland's octave rule. Newland arranged the elements in increasing order of atomic weight. During this arrangement, he noted that every 8th element has same property to that of first element. That is called Newland's octave rule. This rule is applicable up to calcium. Here the options are option 1 carbon, silicon and germanium. The atomic weight of carbon is 12. Then atomic weight of silicon is 28. Then atomic weight of germanium is 72. This 72 is more than calcium. Calcium atomic weight is 40. So it is more than 40. So the option 1 is wrong. In option 2, beryllium, magnesium, calcium. Beryllium's atomic weight is 9. Magnesium's atomic weight is 24. Calcium's atomic weight is 40. So it comes under Newland's octave rule. So option 2 is correct. In option 3 and 4, this gallium and bromine has larger atomic weight than calcium. So these are also wrong. The correct values of ionization enthalpy of following elements are carbon, nitrogen, rubidium and fluorine. Before entering to this, we have to know what is ionization enthalpy. It is nothing but energy required to remove an electron from the outer shell. This energy is called ionization enthalpy. In the periodic table, when we goes from top to bottom, the size of the atom increases. When size increases, the energy need to remove electron is decreases. So when down the group, the ionization enthalpy decreases. Ionization enthalpy decreases. In the periodic table, from left to right, the size of the atom decreases. So we have to put more energy to remove these electrons. So from left to right, the ionization enthalpy is increased. Here the elements, we have to arrange the elements first. Carbon, nitrogen, fluorine. Carbon's atomic number is 6, nitrogen's atomic number is 7, fluorine's atomic number is 9. Then remaining one is bromine. Bromine is a first group elements. Its atomic number is 37. So it needs low energy to remove the electron from the outer shell. So rubidium has a low ionization enthalpy value. Here Rubidium is present in third position. So the lowest ionization enthalpy should be in third position. Here in the option 2, 403 is the smallest ionization enthalpy value. This is for rubidium. Then carbon. Carbon has first highest than rubidium. So the first highest value is 1086. The second highest for nitrogen is 1402 and third highest for fluorine is 1681. So the correct order is 2. Match the following. Here these names are newly discovered elements in the periodic table. This is its official IUPAC name. First one is unanoctium. Unanoctium is nothing but oganesson, which is represented as OG. Then second one is unantrium. Unantrium, its official IUPAC name is nihonium, which is represented as NH. Then third one is unanbium. Unanbium, its official IUPAC name is copernicium, CN. Then fourth one is unalquadium, which its IUPAC name is rutherfordium. It is represented as RF. So the option is 4. Unanoctium is oganesson, unantrium is nihonium, 2 is 4, unanbium is copernicium, 1, unalquadium is oganesson, option 3. So the correct one is option 4.
Match the following. Here they are given the uses and here they are given the organism names. We need to match this. First, food. Among this, the porphyra algae is used as a food. So it can be used as a food. And next, agar. Agar is usually obtained from the gelidinum, which is used for making jellies and ice cream. So agar is obtained from gelidinum. And single cell protein. Single cell proteins, which is usually obtained from the chlorella and also from spirulina, which is usually rich in proteins. And next, peat masses, which is obtained from the sphagnum. So these peat masses have high water holding capacity So they are usually used in the gardening purposes. So the correct option is A. Here from other types of algae like laminaria and sargassum also it can be used for the food, and agar is also obtained from gelidinum and gracilaria, and single cell protein is obtained from chlorella and spirulina. In angiosperm, as a result of double fertilization, the endosperm is obtained. In which of the following seeds the endosperm is absent? The given options are coconut, orchids, maize and castor. First we need to know what is endosperm. This endosperm are usually obtained by the double fertilization process in angiosperms, and this endosperm is the food storing tissue which provides the nutrient So this endosperm is usually absent in the orchids. So in coconut we possess the endosperms, so which is the edible part, and in castor too we having the endosperm, and in corn seeds we possess the endosperm here, but in the orchids only the endosperm is usually absent. So the correct answer for this question is orchids, in which the endosperm is absent. So it is a non-endospermic plant. The given floral formula belong to which family? So this is the floral formula and the given options are Liliaceae, Fabaceae, Solanaceae and Musaceae. First, among these families we need to find which of the floral formula matches it. So we need to decode the floral formula and this symbol represent the flowers are actinomorphic, usually actinomorphic means they can be radially symmetrical at two equal halves at any places. Next, this symbol denotes bisexual flower and next K means which is calyx, that is we have 5 sepals and this bracket denotes they are fused. And C means corolla, they usually possess 5 petals and this bracket denotes they are fused condition. And here A, which denotes androecium, which is a male part in the flower and which possesses the stamens, and it possesses usually 5 stamens, and this symbol which denotes it is epipetalis. Epipetalis means the androecium gets fused to corolla, and this G which denotes gynoecium, which is the female part of the flower, and this gynoecium which has 2. So they are bicarpal, and this symbol denotes superior ovary, and they are syncorpus. So by decoding this formula, the flower is actinomorphic and they are bisexual and they possess the 5 fused sepals and 5 fused corolla, and they had an androecium, 5 stamens which are epipetalis in nature, and the gynoecium is bicarpal, syncorpus, and also they having a superior ovary. So from the option, the matchable family is Solanaceae. So the correct answer is Solanaceae.
What is A in the given diagram? So they have given the diagram of neuron and they are asking about the part A. So the answer will be option 3, dendrite. We will discuss the diagram. So here this is the structure of nephron. Nephron is divided into 3 important parts: the cell body or soma, the dendrites and axon. So here the branched part, it is called as dendrite. The cell body, it is also known as soma, which contains the central nucleus. This is the axon part. So the axon has myelin sheath. This is a myelinated neuron, so it has myelin sheath, and this myelin is formed by Schwann cells. Okay, and in between the myelin sheath we have certain dips. They are called as node of Ranvier, and this is the terminal part of the neuron which is called as axon terminal. So in this question they are asking the part A, that is dendrite. So the correct option will be option 3, dendrite. The ascending sequence of taxonomic hierarchy of housefly is. So they are asking about the ascending sequence of taxonomic hierarchy of housefly. Ascending sequence means it starts from species, genus, family, order, class, phylum and ends at kingdom. So we have to arrange in this order. So we will see the options. Option 1. So the biological name of housefly is Musca domestica. So here domestica is species, Musca is genus, Diptera is order, Arthropoda is phylum. So this is in correct order. This option is correct. Coming to other options, Arthropoda comes first. So the phylum is coming first and after that we have order. So this is not, and next we have genus and this is species. This is also correct, but this is the descending sequence. They are asking about ascending sequence. So this option is not right. Coming to third option, here Diptera is order, Musca is genus, Arthropoda is phylum and domestica is species. So here they are arranged in an irregular manner, so it is not correct. And the last option, Musca is genus and domestica species, order, phylum. This is also wrong because species is coming after genus. So this is also wrong. So the correct option will be option 1. So this is the correct taxonomical hierarchy of housefly. So species Musca domestica, genus Musca, family Mucidae, order Diptera, class Insecta, phylum Arthropoda and kingdom Animalia. Match the following. So here we have to match the epithelium and their location. So squamous epithelium. Squamous epithelium, among the options it is seen in alveoli. So A for 4. Cuboidal epithelium, it is seen in renal tubules. So B for third option. Columnar epithelium is seen in stomach and intestines. So C, second option. And ciliated epithelium, it is seen in bronchioles. So D, first option. So among these options, the correct option will be option 2, where we have matched the epithelium along with the location. So we all know that the epithelium is divided into 4 different types: squamous, ciliated, cuboidal and columnar. Squamous epithelium is present in blood vessels and alveoli of lung. Ciliated epithelium, they have cilia, they are commonly present in bronchioles and fallopian tube. Cuboidal epithelium, cuboid shaped cells which are commonly present in renal tubules and ducts of glands. And finally the columnar epithelium is present in the gastrointestinal system. So here in this question the answer will be option 2.